Good morning, friends. Today we are going to discuss the Python pandas. Before knowing the Python pandas, first of all, we have to know how to install the Python pandas in our system. As we know, in our computer lab, we already installed the Anaconda applications. Hence, we don't need to install Python pandas explicitly because Anaconda Python package is already installed Python pandas library. Before using Python pandas, we have to include or import Python pandas before writing any program in that. Hence, in this particular video, we will not discuss installation of Python pandas, but we will just use import of Python pandas by writing the command import Python import pandas as pd. By writing this, we can import all the necessary files required in Python pandas by using this particular command. Now we will discuss types of Python pandas. There are basically two important data structures of pandas are series and data frames. As we know and learned in last year, NumPy array which have two types. First is 1D array and second is 2D or two-dimensional array. Here the series is very much similar to the one-dimensional array-like structure with homogeneous data types. Unlike NumPy array where we have all the numeric values in series, we can store numbers along with the characters as well as strings. Next, data frame. The data frame is like a two-dimensional array with heterogeneous data. Heterogeneous means we can save different types of data in this particular data structure. Now we will discuss how to create a series and store the values on that. The syntax of creating a series, you can write pandas dot series in parenthesis data which is to be stored, comma index, data types and copy. All these arguments of this functions are optional. We can add this or we cannot or may not. As I have told earlier, we have imported pandas as PD, where PD is an identifier. Since we have already nomenclature of pandas as PD, then instead of writing pandas.series, we can also write pd.series having same number of arguments. Creation of empty series. For creating the empty series, we can write pd.series having no arguments. In this way, we can create an empty series having no values and default data types of float 64. Create a series from n-dimensional array. As we know, in the last session or last year in class 11, we have already discussed the creation of NumPy array. For creation of NumPy array, we have to import one more library, that is import NumPy as NP. Here we will first create a NumPy array by using the above said syntax. Hence, by importing pandas and NumPy, we create a data by using array function np.array, or in parenthesis we can add the number of values. It may be a characters, integers, or it's floats. Here we have created an array having the values a, b, c, d. Now by using the pd.series function, by passing the data as a parameter, we can create a series having values a, b, c, d. Since in this particular function we have not added the index, the default index 0, 1, 2, 3 is already added in this particular series. In another example, we have adopted the same methods, but instead of leaving blank the index field, we have added 4 values: 100, 102, 101, 102, 103. The resultant output will be ABCD along the index value 100, 101, 102, 103, which have already added through the parameter index. Now we will discuss the creation of the series with the help of dictionary. In the earlier session, the last year, we have already studied dictionary is a data structure having in the form of key value pairs. So first of all, we have to create a dictionary having the syntax, above syntax. We have created a dictionary having key A and corresponding value 0, key B and corresponding value 1, key C and corresponding value 2. Now with the help of above dictionary, we can create a series. In this particular syntax, one can be noted that there is no index field is required. Already the key of any dictionary can be act as a index of the series. C, A, B, C are the keys of the dictionary which act as a index of the resultant series ABC having values 0, 1 and 2. Further, if we want to add the index values, we can add this. Here in this example, we have added the index B, C, D, A. The result will be corresponding values of B, C and A will be shown in the output, but in D there is no keys available for this particular name in the dictionary. So the value NaN, not a number, will be assigned to the resultant series of this particular index, that is D.